Hello, thank you for joining us. My name is Richard Newman. I'm a principal engineer with AWS. And today I'm joined by Vidya Mohan, who is a software development manager. Both of us work on Amazon Chime. Today we'll be talking about creating classroom experiences using the Amazon Chime SDK. Amazon Chime is a unified communications product and service. This is really three things rolled into one. We have the kind of end user product that you would expect from a unified communications solution. You can join video meetings, send chat messages, and place calls to the public switch telephony network. We also have a full telephony system called Voice Connector that allows you to place phone calls, receive phone calls, and route calls to your PBX. We have a third pillar, which is what we'll be talking about today, which is our SDK, which is a traditional AWS style builder solution that allows you to add voice and video capabilities to your own applications. Specifically today, we'll be talking about education. Now, we've all spent a lot more time at home in the past few months than I think anybody expected, and that's caused particular challenges in education. Now, educators had to turn to video conferencing solutions like Amazon Chime to provide a continuity of service to their customers. So teachers ended up having to teach through video calls, try to run Blackboard alongside, all of this kind of good stuff. And this has had like three main kind of challenges that we've had to overcome. One is onboarding. So we already have to go through the effort of setting up e-learning solutions, custom applications, Chromebooks, laptops, tablets, and these days having to do that on a diversity of hardware at home where the teacher cannot be present to assist. So that leads to onboarding time problem. The effort of just getting lessons started, getting students with the right software installed. That flows on into problems with identity and authentication. You already have to manage accounts and logins for your e-learning solution for your own product and service. Now you also have to manage identity, authentication, authorization for this third-party video application that you've had to adopt. And those challenges often lead us to make poor security trade-offs. Understandably, when you're trading off the ability to use the product versus security, sometimes security will suffer. And that's led to a bunch of high-profile problems. You probably heard the term Zoom bombing, where someone who knows your meeting ID can just join your classroom setting without passing through your regular authentication flows. And that's a real challenge. And then as we move into actually using the solutions in concert, we find that they don't flow particularly well. So switching between applications, screen sharing, managing content sharing, making sure the right apps are open at the right time, muting and all this kind of stuff becomes a real obstacle to learning. All of this leads to what the slide calls a disjointed classroom experience, and we can do better. So beyond those kind of teaching challenges, we might choose to try to integrate voice and video solutions into our own e-learning product. Great, awesome, let's go do that. Well, that's a lot harder than it sounds. So you might go off and find some solution like Jitsi, various open source projects, and try to produce a solution yourself. Well, that's a very heavy lift. You might do so by going off and finding a collection of open source solutions like Jitsi. You might see the words WebRTC and start to try to integrate those things yourself to deliver a web-based solution. And that's unfortunately a very heavy lift. You'll have a long delivery cycle. Typically, these are not your core skills, and you'll be mired in a pretty long slog through browser compatibility, device compatibility, delivery cycles, building native applications alongside your web-based solution. not to mention having to build and run your own back-end infrastructure, which leads to a significant operational complexity. Like those selective forwarding units, audio mixers, are also accompanied by turn servers so that you can do NAT traversal and deal with firewalls. That operational complexity doesn't just extend to the service itself, it's also the network backbone, a region story, monitoring and availability, and doing so in a way that meets customer expectations for availability and reliability, as well as latency, which is tremendously important in these solutions, typically means that you're having to expand into regions and run capacity that you then have to pay for. And so in order to deliver the expectations, you take on the cost, which is significant. And these days, everybody expects third-party integrations out of your solutions. You want to be able to run machine learning against audio and video. You want to do image processing, translation, transcription, sentiment analysis, recording, cross-service security, and you have to build those integration points yourself, all of which leads to increased time to market, increased costs, and limited feature set. So what's the alternative? Well, we built the Amazon Chime SDK in order to make it easy for you to add voice, video, and screen share, as well as PSTN interop to your applications. And this is built on top of the same regional, reliable, available, low latency, high quality audio and video system that hosts Amazon Chime itself. This brings our expertise in running RTC at scale across 14 AWS commercial regions with all of our carrier partnership, all of our infrastructure expertise in the AWS backbone. And you get to build your applications on top of this foundation with no deployment required. What does this let you do? Well, it lets you build your clients and your service faster. You have ready to integrate SDKs, Swift for iOS, we have Kotlin for Android, and a JavaScript TypeScript SDK for your web applications and Electron apps. And those are ready to go. They abstract away all the complexity of WebRTC signaling, all the difficulties of device management. They have HD video, 720p, 16 streams, customizable bandwidth policies, 250 attendees in a meeting with all of the client-side observer notifications you need for active speaker, signal strength, volume changes when people are talking, all of that good stuff. Those clients bring you screen sharing with controls, and it abstracts over device selection, video resolution, and the emission of client-side metrics. This comes with the back-end support that you need to make this work. You get to use the Amazon Chime media service infrastructure across all 14 regions. You get to use a location service to host your meetings closest to where your users are to reduce latency. I'll talk more about that in a moment. With all the same AWS service health dashboards and monitoring that you expect from any AWS service. And the Chime system comes with all the same integration into AWS services that you would expect. You get to hook all your audio streams out through Kinesis video streams so that you can combine those with our AI and ML capabilities like transcribe and comprehend. You get to hook into Amazon Chime voice connector. So you get PSTN dial-in for your meetings without having to go off and make your own integrations with those providers. And meeting events are pushed out through EventBridge, SNS, and SQS, exactly as you would expect from any other service. The upshot of this is that you get to market quicker, your costs are lower, and the quality is higher than if you rolled a solution yourself. Brief pause for a map. So as I mentioned, Chime is in 14 regions. And this is relevant because your users will not all be in the same place. And you need to host your meetings in the kinds of locations that make sense for latency for those users, as well as the compliance, legal, and regulatory obligations that your solution might have. So this map shows how attendees in various locations will be mapped to regions that optimize for latency. And we have a region location service that helps you do this. But also, most importantly, we actually have service in those regions so that your users in Australia, your users in East Asia can get an experience that works for them. What does this lead to from that looking back at the earlier slides about the problems you come across when you're trying to build an e-learning solution? Well, this leads to faster time to teaching because you're integrated with the authentication story that your application provides. It's available on the web. You don't have to install an application. And you can integrate this with your portal so that you get control over classroom safety. There is no need for these meetings to be accessible to members of the public, to people who happen to guess a 10-digit ID. So your students can be safe and your access control can be linked to your own application. The third point on this slide is that you no longer need to switch between your learning material and your video conferencing application. You've got that integration that you need so that you can bring voice and video and screen sharing, content sharing to your e-learning solution rather than just running them alongside. And that leads to a more productive classroom experience. Okay, so let's dig in a little bit more and make this real and look at the real constituents of this solution. So there's really three pillars here. I'm going to work right to left. We have this stack of media resources: video selective forwarding units, audio mixers, turn servers to let you traverse network elements. And those are all deployed regionally. And that's really the backbone that lets this solution work. And we have the AWS SDK that you all know and love, available in every programming language that the SDK supports, which is quite a lot. It lets you use Chime APIs from your server-side applications to create meetings, create attendees for meetings, and vend join tokens that let these end users actually get access to media resources. So you would typically deploy that SDK alongside your standard server application, however you choose to do it. The real goal in this thing is the SDKs that allow you to build your own experiences. So those, as I mentioned, iOS, Android, and JavaScript. And those are deployed through the same mechanisms we would expect for that platform, for instance, as a node module for React. And these let you just quickly build your solution idiomatically and get it out the door. So how does a typical application structure look? Well, this is the structure that we've seen our customers use successfully. You'll see on the right there that we have a little server-side serverless application in Lambda behind API Gateway that uses the AWS SDK to manage Chime media resources. So that would be, for instance, creating a meeting or ending a meeting, and perhaps doing so on a schedule or in response to some user action. In the top left here, you see the educator application. So typically we'll have a different experience for the educator rather than the learner, just because the educator wants to be able to, for instance, mute all of their students or control which content is being shared. So here, the educator application is the thing that is driving that serverless app to vend resources. And then you'll see both the learner and the educator here are connecting to the Chime media services in the bottom right there. And that's really the media flow. That's how audio and video are being exchanged. And so you'll see this structure pop up a lot because it's what makes sense. It's how these components are meant to work. Now I'm going to hand off to Vidya to talk through some of the more detailed flows through the SDK and the backend service, and also to take a look at one of our solutions. So Vidya, take it away.
I'm going to walk you through a high-level call flow of depicting the Amazon Chime SDK infrastructure before delving into the demo. We begin with a client application either a browser or Electron application built over Amazon Chime JavaScript SDK, or an Android or iPhone application over the Chime mobile SDK. When attendees are ready to join a meeting, they will connect to a server application in their company's account, which creates a meeting by calling into Chime Media Control Plane server in US East 1. Based on the region of interest, our servers place the meeting in any of Chime's media data planes. An attendee is added to this meeting and a join token is provided back to the client application. The client application uses the media data plane URLs to join this meeting in the media region using a secure WebSockets connection. Once the join token is validated, the meeting starts. If you have previously set up AWS CloudWatch events for Chime or provided an SQS or SNS ARN as part of the create meeting request, you will receive notifications for the meeting lifecycle. If you have an IP private branch exchange, session border controller, or other voice infrastructure with internet access that supports Session Initiation Protocol, or SIP, you can also integrate your SIP compatible voice infrastructure with an Amazon Chime voice connector to make SIP voice calls and join from the phones. You would do so by setting up an Amazon Chime voice connector under your AWS account. A SIP attendee needs a join token, much like any other attendee in the call, and will include it in the SIP invite message to join the Amazon Chime SDK meeting. Now I'm going to walk you through a concrete example of a classroom application built by Chime. To set up this application, you will need an AWS account ID and an IAM user with an Amazon IAM administrative access policy to create assets needed to run this demo. Once the setup is done, you can remove this role. To simplify the setup process, the demo ships with a setup script that can be executed in a Cloud9 environment. The team chose Cloud9 as it comes pre-built with AWS CLI, AWS SAM CLI, NPM, and other utilities that simplifies the setup process. If you have an existing Cloud9 environment, you can use that. Otherwise, you can set it up in the AWS console. Once you create a Cloud9 environment, clone our demo application and execute the deploy script. The script can take up to 15 minutes to complete and execute several actions. It uses AWS SAM CLI to deploy a CloudFormation stack, which unpacks Amazon API gateway entries to create, join, or leave a meeting and send a chat message. AWS Lambda functions backing these applications are deployed. Amazon S3 buckets to store the executable version of the application, and IAM roles associated with the Amazon Chime SDK policy that would be needed for meeting creation and attendee management. It then sets up a simple chat application using Amazon API Gateway and WebSockets. Finally, the script uses Electron Builder to build Mac and Windows binaries of the application and uploads them to S3 using the AWS CLI. At the end of the setup, a URL is printed that can be shared with teachers and students alike to download the demo. I'm going to pause and show you how this application looks like before going into the details. I will be creating a classroom and joining in as myself as a teacher. Richard will be joining in as a student. Once I'm in the classroom, I have audio controls, the ability to share my video, and chat. I will soon see Richard joining in as a student in the roster. Hi, Richard. I can also share my screen at any point. Once I'm done, I can end the session. I'm going to go a little slow on the actions I executed previously and match them to the call flows in the architecture we saw earlier. When a teacher downloads an application and opens it, they will see a dialog box where they can enter their class name and their name. A drop-down box lists all of Chime's 14 media servers across the globe and is automatically pre-populated with the media region closest to the teacher for an optimal meeting experience. When they hit continue, a HTTPS request is made through Amazon API Gateway, which invokes a Lambda that makes a create meeting request to the Chime media control plane and allocates resources on the media servers in preparation for the classroom session. The response contains URLs of the media servers that client applications can use to connect to. A second request is made to register the teacher as an attendee. This response contains a join token to authenticate them into the meeting. Recently, Chime released a new API that allows creating a meeting and adding an attendee in one single action. The API is called Create Meeting with Attendees. The join token, along with the meeting URL, is used by the classroom application to join the Chime Media data plane servers. When students are ready to join in, they simply enter the name of the classroom and along with their name and click continue. Upon joining the classroom for the first time, the teacher and the students are prompted with pop-ups to grant permissions to share their audio, and they have to explicitly click the OK button to continue. This holds for access to video devices as well. The code snippets on the right side show the lines of code to enable this experience. As students join, the roster on the right side is updated with the names of everyone in the session. Against each name, you will see whether they have their audio or video enabled during the session. At this point, the teacher is ready to begin instruction. At any point, they can mute or unmute themselves, switch on their camera, or send chat messages. Video is forwarded to all participants in the classroom session from our media servers. Teachers also receive videos of students that chose to enable their video. Underneath the application, audio of each participant in the classroom is sampled at 16 kilohertz and encoded using the Opus codec and mixed in the cloud. Video uses hardware acceleration when available to support resolutions of up to 720p. At any point, up to 250 concurrent classroom sessions can be hosted in a single AWS account. Teachers can manage the experience by enabling a focus mode, which mutes all the students. This is achieved by broadcasting a special message to the students. When the student's classroom application receives it, it silences their audio. It also prevents them from unmuting themselves until the teacher releases the focus mode. This allows the teacher to present their material uninterrupted. Teachers can also share their desktop with a video-based content sharing experience using an inbuilt screen share picker that ships with this application. Chime allows up to 2 content shares to be present in a meeting session. This concludes this demonstration. Assets created by this demo, as well as any Chime meetings hosted, will accrue to charges in your account. Once you're done, you can delete the CloudFormation stack that was previously set up. The usage details can be obtained from the AWS billing console under cost and usage reports. At this point, I'm going to switch the presentation to Richard, who will share the GitHub repository with the demo code.
Thanks, Vidya. Okay, so we're going to go and take a look at this GitHub repo. So this is all the code, front end and back end, that Vidya just demonstrated. So I'm going to switch over to Visual Studio Code, so we can click around and explore some of this React code and server-side node. Okay, so here we are in Visual Studio Code. So you can see on the left here, I've got a checkout of that repo. And you can see it looks like a pretty ordinary node project, and indeed it is. So we have this package JSON with our various build scripts and our dependencies. This is kind of complicated because we end up building an Electron app out of this. And you can see here on the left, we have two really interesting folders. We have a serverless folder and the app folder. These are the two apps that we're talking about here. You can see that the serverless folder here has, a pretty standard CloudFormation template. See, we have lambdas and policies and a few routes going on here so that we can hook things up into authorizers. And that's relatively standard stuff. You'll see here we also have a handlers file, and this should be pretty familiar to anyone who has built serverless apps before. So let's dig into the app itself. This, you can see, is a pretty standard looking React app with hooks and components, some types, because this is a TypeScript application, with the standard package applications. So I'm going to go and take a look at our root component here, which is where the app really starts. So again, fairly standard component tree with hash-based routing, internationalization to give us strings. We have a couple of providers here that are how we map some of the Chime state into the React component tree. And then we get into this routes router. So I'm going to click through to that, and we'll see how this app is structured. You'll see here that we have 4 main routes. We have a classroom, create or join, login, and home. I'm going to ignore login and home for now because we're looking to see a few particular things. So I'm going to click through here into this create or join. I'm going to show you how the actions taken on the client here reflect through into that serverless application. So let's take a look. So you'll see this is all modern React. We're using hooks extensively, use effect, and these functional components. And the purpose of this component is really to do one thing, which is capture the person's name, a region selection, and a classroom name, and then push off to this classroom route. So where do we get the region from? Well, that was pre-populated in that drop-down box that Vidya showed you. And we call off into this Chime provider. So this Chime entity is provided by the component tree. We call this lookup closest Chime region function. And that's really simple. That's just a fetch to this nearest media region endpoint, and then we pull some JSON out of it and look it up in this array of supported Chime regions. And so this relies on the AWS network to find where is closest to you. And so in this case, we'll be citing these meetings near wherever the teacher is, which is usually a pretty good compromise. You can, of course, apply whatever sophisticated logic you like to this point. So once we have those things, we push off to this classroom route. So let's go back to our routes structure here and see what Classroom looks like. Well, here you'll see there's this meeting status provider. It turns out that that's actually interesting. Meeting status provider fetches those query parameters, that region, then the meeting title, and it uses those to make this call into create room. You'll see we're back to this Chime SDK wrapper file again, into this create room function. And again, this is actually relatively straightforward. We fetch this application URL and we make a call off to this join endpoint. Now, if we hop off to that handlers file again, you'll see that create or join, which is down here, this takes in those query parameters like the title. It creates a meeting using the Chime SDK. This is the AWS SDK with various parameters which were supplied. It pushes that configuration into DynamoDB. That's that put meeting function. And then it builds this join info bundle, which we then return back to the client. And that's what it needs to be able to join the meeting. So that's really it for join. You'll see the client figures out what meeting it wants to start. It hits this serverless endpoint running in AWS Lambda. And then that uses the Chime SDK to go off and create a meeting resource and vendor token to allow you to join it. So let's go and look at something a little more complex. Let's go look at the roster. So if we look here at the very bottom of this join function, you'll see this initialize meeting session with the configuration that we just got from the service. So if we click through to that function, this is where we actually join the meeting. We fetch a device controller to manage the audio and video devices. We set up a meeting session with the configuration that we got and that device controller. We list some input devices and output devices, and we pick one and go and use it. We publish an updated device list. And then you'll see here we subscribe to attendee presence. And this is a real-time API. So it's called real-time. So this will be fired every time an attendee joins or leaves. So you'll see here we have relatively straightforward code to check whether someone is already present or not, put them in the roster, and then publish that roster to anyone subscribing to it. I'll show you that in a second. You'll see we also, down here, each time we get a roster change, every time a new person joins, we subscribe to their volume indicator. So this callback will be invoked every time a speaker causes their little microphone indicator to flicker with these various parameters: muted, volume, signal strength. And all of these calls end up in publish roster update, which if I click through, you'll see that this invokes a set of callbacks with a certain throttle. Now, how are those callbacks actually used? Well, if we go and search for roster update callbacks, you'll see that we use the subscribe to roster update. And if we look for where subscribe to roster update is used, you'll see that these hooks, use attendee and use roster, let us track those roster state changes. And that's the foundation of how we build a component like roster, which calls use roster, see here, and then as a result renders this attendee map using that roster data. So that allows us to map those SDK concepts, which are already abstracted by the SDK, into React concepts so that we get to build this component tree. Relatively straightforward. The last thing I want to show you today, two things really. One is grid views and the other is the screen share picker. So one of the really tricky things about building a video conferencing app is that the layout gets quite complicated. And so if we take a look at remote video group, you'll see this is actually just 150 lines of code, which displays up to 16 video tiles with and without content share with your local video. And it does so by mapping, handling this observer notification for video tile did update to bind video elements. And so this is the magic in this bind video element call. And this, in combination with not a great deal of CSS, this is using CSS grid to do the layout. These two piles of code give you a video grid, which you can use in your applications, it's a tricky thing to design and build, and this is ready to go out of the box. The other thing that Vidya mentioned earlier is screen share picking. And this is also a pretty interesting piece of code. So this is something you kind of get for free out of browsers, but not from Electron. Electron has this desktop capture a source, but you need to build an experience on top of it. And this screen picker component does exactly that. It uses the sources available from Electron to capture windows with a thumbnail and provide you a picker component from which you can choose which screen to share. And again, this is a great accelerator for you getting to market with your solution. The SDK abstracts away a lot of the browser and protocol and media handling stuff. And then these demos and solutions that we provide give you more complex building blocks that let you deliver solutions. So now you've heard a summary of some of the problems with applying video conferencing solutions to e-learning. You've seen how the Chime SDK can accelerate your development, can let you leverage Chime's multi-region, highly available solutions. And you've also taken a look at a demo and some code that shows how the Chime SDK can be specifically applied to e-learning problems, which I hope has shown you that you can use that to deliver solutions to your customers. So I wanted to close with a couple of examples where our customers have done exactly that. This example is BeSmart, one of the leading e-learning solutions in Italy. They were able to build a solution on top of the Chime SDK in 8 days and get this to market to allow learning to continue during COVID lockdown, which is an incredible achievement. I'm sure they have excellent developers, but I'm extremely proud how the Chime SDK has given them the tools they need to deliver a solution of that level of complexity in that time frame. Just incredible. This next example shows that our definitions of e-learning really isn't limited to schools, K through 12 in the US. MindBody is a wellness solution. So they stream yoga, personal training, still a kind of learning. And they also were able to put together a solution which met their scalability, security, and integration capabilities in a matter of weeks. And they're in a fascinating position of they too are providing a solution to their own customers with end users. And so that we're able to accelerate their development so that they can offer their solutions to their wellness businesses. It's also a really wonderful thing. That concludes the slide part of this webinar. Thank you all for coming along on this journey with us. We're going to drop in the chat links to this main Chime SDK page and also the classroom demo itself and the JavaScript SDK. So you can click through and read the code, check them out, and try building out your own solutions and running that demo. And now we're going to shift over to Q&A. Thank you so much.